So you recording
Sir,
yes.
so today test
Yes.
one, first one numerical was there. It was
Which one? Which one? What happened? So you are told to draw the red tree diagram block and tackle diagram. Did you draw? I told you to send on my WhatsApp. No one has sent till now. Or in the group WhatsApp also, no one has sent. Were you able to do that one or not? Whatever, no response. Yes. Am I audible or not?
Audible, sir.
Audible. What happened? Did you solve that one?
No, sir.
No, sir. Why not? So you were told
Not.
to complete for n equal to 4 and 5. So when n is 4 and effort is downward, what will be? So 2 pulley will be in the upper block and 2 will be in the lower block. So 2 will make an upper block. So what will be? These 2 will be connected together. Upper 2 will be connected together and lower 2 will be connected together. The load will be connected to the lower one. So we have to apply effort in downward direction. So we'll start from effort will be applied where? Topmost or lowest one?
Topmost.
Topmost. So we will start the string from here. Okay. So here is effort. So from this one, from the movable, from the fixed block, the string will directly come to the movable block. It will not pass through this pulley. Movable block, the lowest one. Now from here, it will go to the second one because this is already occupied. So it will move from here, it will come to this one. Now from here, it will come to this place. Now here nothing is lying vacant. So what will be at last it will be connected to the frame. So we will have to show the tension in lower block. So these are the four string which is connected to, or four strand connected to the lower block. So in each one we will see so that tension is E. This is T here. This is T which is equal to the E first. In the actual one, what will be here also tension is acting downward, here also downward, here also downward, here also downward. If you are not showing that, no problem. But this much you have to show. So this is the position of effort, this is the position of load, and these are the direction in which tension is active. So in this case, what is happening? This 1, 2, 3, 4. This 4 tension is acting on this movable block. So this 4T will be equal to L. That means this and this T is effort. So this ideal mechanical advantage will be L over E, which is 4. Ideal mechanical advantage or velocity ratio. Afterwards, same way, mechanical advantage if it is asked, then what is the useful load that you have to consider? So this mechanical advantage will be L over E, which will be 4 minus X over E. Efficiency will be 1 minus X over L. That will be the general one. Mechanical advantage will be velocity ratio minus X by whatever it is left. Same way you can find L minus X over E, then L by E is 4. So while solving the numerical, we will use this one. What is the useful load and what is the effort? You can use this also, no problem. If this is given, useless load is given, effort is given, then this one 4 minus this. This is when we are applying effort in downward direction. Now you try to make when effort is applied in upward direction. So as the pulley is given, so 2 in fixed block, 2 in movable block. So if we are applying effort in upward direction, what will be? We will have to apply effort here. Now you complete.
Sir, can you read the lines which you have written? 4t is after 4t is equal to
And
L.
4 and effort is upward. That is inconvenient. So effort we are applying in inconvenient direction.
Sir, please read after 4t is equal to L next line from there.
No, that is previous one, not this one. You are doing previous
Next one,
one.
sir.
Next one is not this one. Next one we have to complete first this one. First to complete this one, then only we will modify this one. This is not this one.
Yes, sir.
Did you complete this?
Yes, sir.
How many tension is balancing the load? How many tension now you are ejecting on the load? On the movable
Four.
pulley, how many tension? Yes?
Four.
Wrong.
So which one?
This one, this one.
Down one, sir.
Down one over.
Oh, up one.
Running now or what?
Yes, sir. Now I can, sir. Sorry, sir.
Now when it is over. Down one over. Now you complete over some other.
No problem, sir.
Now we are doing n equal to 4 and effort is upward direction, which is inconvenient. If total number of pulley is 4 and effort is applied in upward
5
direction.
tension. 5 tension.
5 tension will be there, yes. So why joining late? I already waited from 9 to 9:04, then also very few are coming. Now how many are there?
31, sir.
Now 31. No, 31 including me. So student are 30 only. Coming very late. This is the first period, they're also so late. Okay. So in this case, what will be? We will start from here. We will go to the first one here now. Because from movable, we will go to the fixed one. Now from here, fixed to movable. Movable is already occupied, so it will directly come to this place. Now from here, it will come to fixed one. Fixed one, this is occupied, so we will come to this place. Now here it will be connected because no pulley is lying vacant here. So how many strands are connected to this movable one? 1, 2, 3, 4, 5. So in all these 5, you will have to show tensor which is in upward direction. And one tensor is this one which is equal to equal. So at least we have to show this one. So what will be the velocity ratio?
5.
5.
5. So in this case, 5 tension is balancing the load. So effort, that is 5 effort is this one. Sorry. Mechanical advantage will be 5 less than 5 efficiency cent. So if you are given a block and tackle of 4 pulley system has mechanical advantage 4.5. That means previous one can't be. So this is the situation. If this is off, but generally in board only convenient one is off. Inconvenient very means till now I have not seen the question which is based on inconvenient. But you must have some knowledge about this also. Okay. Now similarly, if it is total number of pulleys 5, here will be 3, here will be 2. If effort is convenient, inconvenient, then 3 will be down, 2 will be up. So this way you can do number of pulley 5 and 6. So 5 and 6 you have to do your work yourself. N equal to 5 and N equal to 6, both the case. Convenient and inconvenient. So 4 figure you have to draw yourself. Okay, so in block and tackle arrangement, I think in machine only this much we have to do. Now some numericals related to this block and tackle arrangement. A 4 pulley
Sir,
system.
what have you written in the top right one?
Yes. That is homework. Where total number of pulleys 5
What have
and
you-
total number of pulleys 6.
Okay, sir.
That you have to do yourself, both the cases, inconvenient and convenient. So you will find what is the velocity ratio, what is the ideal mechanical advantage in both the cases. So it will, natural what will be here? If N is 5 and effort is downward, velocity ratio or ideal mechanical advantage will become 5. If inconvenient, that is upward, then this one will become 6. One more than that. Already we have got the formula, or we have learned that general formula, general relation. So if you are to recall, then what will be? Okay, we'll write again. So velocity ratio or ideal mechanical advantage for block and tackle arrangement. This will be equal to N, that is total number of pulleys. Well, if effort is downward. Or we say convenient. nothing is mentioned in the question, then it is convenient case. It may be n plus 1 if effort is upward. That is inconvenient. Or this may be equal to number of strands. Or number of strands balancing so whatever the number of strings will be passing, that is so this is the general way to recall about the velocity ratio or ideal mechanical advantage of block and tackle arrangement. Okay, now suppose numerical we will solve. A poor pulley system lifts a load of 1500 Newton when effort applied is 400. Find first is MA, second is efficiency, third is useless load, effort required to lift a load of 2000 Newton, new MA and efficiency of the system. Okay, so these are the 5 questions. Yes. So what is happening here? Mechanical advantage. Load by effort
3.75.
3.75. So here it is used to lift load this much. That is, it is used for load. So 1500 over 400. So it is 3.75. Now, what will be the velocity ratio? Velocity
Four.
ratio 4.
Four.
And it is
Four.
4 fluid system. So if the effort is applied convenient direction downward, it will be 4. If effort is applied inconvenient upward, then it will be 5.
5.
And mechanical advantage is 3.75. So we will consider 4 only, not 5. If it is coming more than 4, then that situation may.
Yes, sir.
So here velocity ratio you will consider 4. This is not given the question paper. Or that you are given this one, 4 pulley system. That means you are supposed to know what is the velocity ratio of this system. That velocity ratio will not be given in the question. Now efficiency we can find. So ME over VR. So 3.75 over.
11 by 12.
Yes.
15 by 16.
Not like that. Not give answer from this way. Decimal fraction.
Okay, sir.
So 0.9.
0.9.
So
3.
93.75%. Okay.
Yes, sir.
Now useless load. If you forget that formula, no problems. What will be here? This velocity ratio is ideal mechanical advantage L plus X over E. So if you are forgetting that formula, suppose this X is what? E VR minus ME. If you can't recall, no problem. We'll use this one only. So this 4 will be equal to 1500 plus X over 400. So this X is 100 Newton. If you are using this way, then what will be? This is 400. Newton. So either this way or that way you can find, no problem. Now this one, what will be?
533.33 Newton.
5.
33.33.
Okay, any other? So many times we have told you this
50.
with this one.
50 Newton.
When we change the load, its mechanical advantage will change. Mechanical advantage of a machine not constant. Velocity ratio will be constant. So
Then my
velocity
answer is
ratio will be same. Mechanical advantage will not be 3.75 now. Now it will be
50.
something else.
8,000.
So what will be the effort required? How you find?
8,000
VR is
Newton.
equal to effort by
So
load.
velocity ratio and useless load will be same because same block and tackle we are using. So pulleys are not
Yes,
changed.
sir. Yes,
So
sir.
useless load, that is pulley is same, string is same, friction will be same. So useless load we are not changing. Only useful load is changed. So this velocity ratio will be again L dash, that is changed over V dash. Ideal mechanical advantage. So what will be dash? 2000 plus 100 by velocity ratio is 2. Useless load is already calculated 100 Newton. That is not going to change. 525.
Yes, sir.
So 525 Newton will be the new effort or will be the effort required to lift the load of 2000. So mechanical advantage will change if you change the load. Velocity ratio will not change. Useless load will not change if there is no change in the construction of the machine. Now, what is new mechanical advantage and new efficiency?
3.80.
So mechanical advantage will not change. It will be increasing. If you increase the load, mechanical advantage will increase. Efficiency will also increase. So this new mechanical advantage will become 2000 over
3.8, sir.
3.8. And this new efficiency will be
38, sir.
0.9.
0.95.
95.
Yes, sir.
So when you are using the same machine or larger load, its mechanical advantage will increase and efficiency will also increase because the useless load in comparison to the total load will become less. Okay, so the Suppose you are given a pulley system with one fixed and three movable. Is used to lift a load of 1600 Newton. Okay, find the minimum effort needed. Okay. In the above question, if weight of movable parts okay, okay, do this one.
Mean effort is 200 Newton, sir. Sir,
Got
yes, sir.
how much?
First one 266.66 Newton.
First one?
266.66 Newton.
No, it is wrong.
400 Newton.
200 Newton.
First one you are asked, find the minimum effort needed. Nothing is mentioned about the machine. So we will treat it as ideal machine. It's not given useless load here. Useless load is given here in the second part. Mute your voice, so these are
200 Newton will be the answer.
yes,
400.
200 is the answer. So minimum right here, velocity ratio is 8. Ideal mechanical advantage velocity ratio 3 movable pulley. So what will be 2 to the power 3? So ideal mechanical advantage or velocity ratio will be 2 to the power number of movable pulley. Here it is one fixed and other are movable. That system is used. So minimum effort needed will be so 200 Newton.
So this is first system of lever.
First part. If it is ideal, then only.
So
Now
how
the
will
second
find?
is given in the above question. If the weight of movable part, that is x, you are given. So in this case, what will be? When x is 200, what will be the effort? $1,600 plus 200 over 8. How much? 1800 by 8. Okay, now the teacher will.
225 Newton.
Yes.
225 Newton.
225.
Yes, sir.
So 225 Newton not will be required. So if what we got, what will be the efficiency? Now you will find mechanical advantage. So MA will be 2000, sorry, no, 1600. 1600 over 225. And efficiency 25 9 25.
8, sir. Efficient. MA will be 8. MA will be 8.
64 over 9. Okay.
No, sorry.
So this one will be 64 over 9 into 8. Eight by 9, right? Or 89%. One.
Yes, sir.
So now you solve the problems of your book. Today you have to give the test also. Have you completed?
Yes, sir. Given, sir.
In afternoon I will get it.
Yes, sir.
Okay, the next shall discuss the problems. If you will have any doubt, otherwise we will start next chapter, calorimetry.
Sir. Sir, pivot point and fulcrum are the same thing, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.
I was having a doubt, sir. Hard, sir. Doubt of it.
Then ask no what you are waiting.
Sir, when? Sir,
Video past है.
yes.